Welcome again to the Kairntech webinar of today, where we will introduce you to a scenario about document analysis and how we can apply artificial intelligence methods, or more specifically machine learning methods, in order to help you. I'm joined today by my friend and colleague Vincent Nibard, and this is what we have prepared for you. So first of all, again, welcome. We are happy to have you with us. We will be, we expect a show of about 1 hour that we split between myself talking, Vincent showing you live what we describe, and then leaving a couple of minutes for you to ask questions. We cannot directly make that interactive, but we encourage you to use the chat tool. So the platform here has a chat tool. We will try to keep an eye on that. So if you have questions and comment, please use that, and we will try to make sure that we go through that and keep the questions and try to provide you with a couple of answers. Also, the webinar is going to be recorded, and we will make the recording available to the registered users. So you don't need to take notes, just lean back and follow the show. And we do these webinars regularly. So if you want to stay informed about what is coming up, please drop us a line at info@kairntech.com, and you will be notified about things that we have on the agenda, and you will make sure that you don't miss the next webinars. So who are we? As I mentioned, you have two presenters today. The first one is me. My name is Stefan Geisler from Kairntech. I'm a co-founder of Kairntech. Before co-founding Kairntech, I spent a number of years at Themis that I had already also co-founded a number of years ago. And all in all, I have spent now more than 20 years in the field of applying natural language processing to industrial challenges. If you want to know more about my background and what I have been doing for the last couple of years, you're invited to join, to take a look at my LinkedIn page that I have given here. And the second presenter today is Vincent. Vincent, are you with us?
Yes, I'm here. Hello.
Yeah, okay. So Vincent, please present yourself.
Yeah, hi, I'm also co-founder of Kairntech. I'm more responsible on the product side. And I used to be a sales director at Themis for a number of years. So like Stefan, some background, more than 20 years experience in natural language processing. And if you want to learn more about me, you can visit my LinkedIn page as well. So welcome.
Perfect. Thanks, Vincent. So we proceed with the next one, and that is about the company where we are from. So we are from Kairntech. Kairntech is a pretty young company. We have established the company in December 2018. We are 10 partners, and the bulk of our team is in Paris and Grenoble, or more specifically Milan, where also Vincent is sitting, and I'm sort of the outpost here in Germany, in Heidelberg, more specifically in Neckargemünd. If you want to know more about Kairntech, you're invited to take a look at our website. Here you see pretty much the rest of the team, people who also have spent years and years and years in the field, in various functions involving software engineering, applying machine learning, but also sales and management around these topics. And so the team comprises experience, or the team has collected experience in previous functions at, for instance, Xerox, IBM, or Themis, or other places. And although the company is pretty young, components that under the hood are working in our software are in production today at places like the CERN, the NASA, the EPO, and others. So there is, although the company is pretty young, also already quite some tradition in what we are doing. And let's proceed in order by describing the problem that we are going to address today, and that is going from documents to information, to data, because it's a truism. Everybody knows that in a lot of business cases today, in a lot of business processes today, data is buried in unstructured documents that could be contracts, reports, customer feedback, websites of partners or the competition or places like that. And it can be pretty cumbersome and time consuming to identify, extract, and compile and make available this data for downstream processes. And these processes need to be efficient, which is made more complex by the fact that documents are unstructured. If you impose that to, let's say, a table that has a much more rigid structure. So in many cases, there's no simple way to extract, to identify and extract this information from the documents. And this is where we are, where we come in. For the sake of today's show, we have selected a scenario around the analysis of public tenders. So a lot of companies depend on their capacity to keep a close eye on public tenders that are out in order to not miss a business opportunity. So that means that you need to regularly scan, is there something where I can make money? Is there something where I can win a project for my business? Again, for the sake of example, let's take a look at this website here that the European Union has put up. The TED, Europa EU TED Browse website that gives me access to the public tenders that are out at a given moment. I can browse with certain metadata. I can do a full text search. And sometimes the categories make it a bit hard to find the things that I'm interested in. So for instance, if my business is, let's say, construction, I would certainly look into that sub-branch here that we see on the right. But as we see, there are many different sub-branches. So how can I make sure that I don't miss anything? Either way, I must accept the metadata that TED is offering me. So I must live with that. If I open one of these documents, this is about what we get. It's not really a totally unstructured document. It has some structure. So there's a canonical way how the sections are called. But still, once I have done my search and I find a couple of dozens, maybe a couple of hundred tenders, I need to sit down, download them, read them, and find the ones that are interesting for me in order to answer questions like, what is the next one that I need to submit a proposal to? Which one is upcoming next? And which one is in the core of my business? And so on and so forth. And this takes valuable time. It's error prone. It's feasible maybe for a couple of dozens, but if there's 1,000, I actually do not want to do that by hand. So what can we do? The documents seem to be pretty, let's say, structured in some places. So for instance, when I'm asking myself, when is the tender due? I take a look here and there seems to be a pattern. As we see, there's 2 digits, slash, 2 digits, slash, and then 4 digits. So that's pretty easy to recognize. But even here we see variation. So we see that in some documents, not even that simple pattern is maintained, but there's another pattern. It's 1 digit, full stop, 1 digit, full stop, and then 4 digits. It's not as easy, and that's a very easy example. We will see more complex examples later on. One typical approach might be to sit down and write rules. So one formalism to write rules is regular expressions. That's a great approach to find simple patterns in documents. But as the information that you are looking for becomes more complex, this can become more complex as well. And regular expressions are pretty very sensitive to even the slightest changes. So you omit a space or you add a full stop, and then for you and me as a human reader, it still looks like the information that we're looking for, but the regular expression breaks down. And also it's a pretty steep learning curve. So simple patterns are okay, but if you do that on a more complex, a more sophisticated level, it can become pretty complex. And again, the types of information that we are looking at here, for the sake of example, for the sake of this webinar, we have chosen a simple example, but there are, of course, many, many more complex types of documents for which rule-based approaches, and more specifically, anything that you need to sit down and code for yourself, may give you a hard time to find the information that you're looking for. But there's a new paradigm, as we all know. Machine learning shifts the whole task around. It's not about writing code, but it's about showing the machine examples of what you're interested in, and then let the machine learn itself how to extract that. So you don't need to code, you just need domain expertise. And it turns out that this is much better to handle variations. So many of the public test and evaluation corpora today, where many, many people apply their methods, if you look at the top of the list, in many places, machine learning methods today represent the state of the art. So it's very hard for other approaches to attain the same level of quality. Machine learning has advantages in terms of quality. And now we stop talking in theory, but we go to a live scenario, for which I'm passing the word on to Vincent. Vincent, are you with us?
Yeah, do you hear me?
Yes.
Okay, so maybe you can go to the next slide.
Uh-huh.
And then, yeah, perfect. So today I have the mission to show you a live demo. So it's still challenging, but I'll do it. So as Stefan explained, we will deal with call for tenders, public tenders, as a document. And our objective is to build a system to automatically extract three key information from all the tenders. The first one is the answer due date. The second one is the total value of the tender, and the third one would be the object of the tender. So for that, we will go through 4 different steps. The first one is to create and enrich a data set. So it's a set of examples of or counter examples that the machine will learn on. Then we will go to an experimentation, meaning that we will test different algorithms to see which one is the best one. So we will go to some quality comparison. This is the yellow round circle, where the goal would be to assess the quality of each and every algorithm and compare each others, and finally select the best one. And then we would like to deploy the model in production in the customer workflow to be able to analyze the new upcoming tenders to be analyzed. And then finally, but that I won't show you, it's the last circle which aims at getting feedbacks of users so as to iterate and to enrich the data set so as to improve over time, or to maintain at least, to maintain over time the model. Okay, so what I propose to do is to share. Let me know if you see my screen.
Yes.
Stefan, could you confirm?
Yeah.
Okay. So this is the Kairntech Studio. So it's a SaaS platform, multi-users. So here I'm going to log in into this platform, and you see here a number of thumbnails. And behind each thumbnails, we manage a project. So it means that here you can see that I've got a different project on different topics. We can manage projects on patents, on contract analysis, on case law here, on news articles. We can manage different projects like categorization with air flight intents and SMS spam. And of course, also what I'm going to show you, project dedicated on public tenders that we have here. So as you see on each project, we manage a corpus of documents. for everyone, of course. And especially for large documents like patents, for instance, we cut every document into segments, and I will show you why we do that. And associated with the document, we have a number of annotations. So it's directly the kind of job that we do to annotate content to create a data set, examples and counterexample we want to learn on. All right, so here, the way to create a project is really straightforward. You just have to click on the plus button to give a name on the project, to select an image. And here you can select the type of NLP task you want to perform. So today, for the time being, we have two different tasks, name entity recognition and categorization. But soon we will support other tasks. Okay. So basically, I have already created the project. I've already imported the document just to save time regarding the demo. And here I've got this new project here. This is the sandbox, where you see that I've got more than 800 documents. No annotations, okay, I did not do anything, I haven't done anything. And on the right side here, this is the project that we will review later on. It's exactly the same corpus of document with some annotation. All right, so let's go in this first project, which is my sandbox. And then let's go directly. I have already imported the document in the platform. And I present you here an example of call for tender. So you see that it's pure raw text, I would say. It's long text, okay. And you see that here we have what we are looking for. So for instance, the title with the scope of the object of this call for tender. Later on, we have this total value, that we would like to extract automatically. So it's a long tender, of course. And at the end, you have some dates that we are interested in. The first one is, of course, the answer due date, I would say. You have other dates here, and at the end, also another date, okay? So here, what we want to do again is to build a system able to extract automatically 3 labels. So we are going to define these 3 labels. So the first one is the answer due date. So let's write it like that. The second one is the total value. So let's say value. And the third one is the object. Okay. So now let's go back in the document view. And then I activate my marker here on the top right. And you see here the 3 labels I've just created. So let's select the first one, object. And you remember I was able to here select the example of the object of the tender. So then I can go below, select the value, which is here, if I'm right. All right. And then I can select the answer due date, which is really at the bottom of the document, which is here. So you see here that we have all the dates. The second one is the same, but anyway, what is interesting for us is this the answer due date, which is here. So you see that here I can then go to the next document and so on and so forth, but it's very time consuming. It's painful. So the first way to go faster is to go in the Explore view here. And what we have done basically is that we have segmented all documents, all tenders in a kind of a segment or a snippet that you see here. And here, everything has been indexed by a search engine. So that means that I can type some keywords here, like this one. Oops. All right. And here I see that I've got some potential relevant segment for me where I can find if I want to focus on the value, the total value of the tender, and potentially I can find some good candidate, good example. So let's go through this list, and here I see that, for instance, yeah, this one is exactly what I'm looking for, so that I highlight. So at any time I can remove or highlight the piece of information I'm looking for. So let's go through and let's take some very simple example here. So again, I do something simple here for the sake of simplicity. And what you see here is that automatically behind the scene, a job has started. And what does that mean? It means that the system has started learning the examples that I'm currently annotating. Okay, so this is very important because it's a way to go even faster than using the search engine. Okay, so in a few seconds we will have a pop-up that you see here that recommend me to go in the suggestion view here. And here the view is a bit different. It is some candidates that my system, my very first model has found, and that I have to validate or invalidate. And this is how we can speed up the creation of the data set. Okay, so here this is a good candidate, so I validate, and then automatically the segment is go in the data set. At any time I can invalidate a segment. I can redo it to correct. Okay, so I'm not very lucky because all the propositions are pretty good. But imagine that I can select another piece of a fragment of text, or I can select the answer due date if by any chance here I have a date or something like that. Okay, so I can do all what I need to do in this view. So, and then of course I can go. So here it's a good example. I have to correct this proposition. Okay. And then select and go from one segment to the other segment and so on. Okay, so after a while, I can go to the dashboard and see that, okay, it will refresh, that I've already done 18 annotation in few minutes with the different labels. So of course, I have mostly done some annotation on the value label. Okay, so now imagine that after 1 hour, so I keep working on this annotation, and after 1 hour, I can show you where I am. So I go back in the dashboard, and here, just the time to refresh the application, you see that I have already annotated more than 400 annotation on the 3 different labels. Okay. So then I can go back in the Explore view, and here I've got some filters. Since everything is indexed by the search engine, I can filter and select only the segment that I have annotated, which are in the data set, and have a look on what I've done so far. So again, at any time, I can remove the annotation, I can create a new one, I can correct, I can make some amendments, and so on. If I want to focus, for instance, on the value, I will filter on all my data set on the value and check if everything is consistent or not, and optionally make some correction. Okay, so that's fine. I've got this data set. I consider that it's a decent work. And now I want to experiment. In other words, I want to test different algorithms to see what could be the best model, the best algorithm on this data. So I go in the experiment view. So here I've cheated a little bit because I've already done one experiment. I already done it because it takes more than 10 minutes to train the algorithm. So I didn't want to spend the time during the demo. But let's imagine that now I want to create new experiment and compare with this existing model. The first thing is that I can select different frameworks. So here today, for the time being, we have 3 frameworks, and we can very quickly select one of them and create a first experimentation. I mean, here we use the default parameters of this algorithm, meaning that I'm not data scientist, I'm just domain expert, and I just want to create some very standard experimentation to see what could be the best algorithm. Okay, so now imagine that I have more skills in data scientist, and I will select again this framework CRF, and then I will open the show advanced parameters, where I will be able to fine-tune the training system. So it means that since we want to train the system, I have to split the data set between train and test. And at the end, I have access to all parameters of this algorithm. Okay, so imagine that I just want to change the algorithm and keeping all the parameters. So it's more complex because here it's more dedicated for data scientists. Again, I would like to test the third framework, Spacey. And here, same thing, I'm going to, I have access to all the parameters. And for instance, I want to change the number of iterations of my algorithm. Okay, so now I have 3 experiments ready to be run on my system. So what I'm going to do is to click simply on this button, on this button, on this button. And then you see that here I've got 3 jobs running. And you will see that in parallel, we will train all experiments on our platform. So it should start, the 3 will run in parallel. So it may take more or less time, depending on the algorithm, of course, on the number of iterations we want to perform. So Spacey will be a bit longer than the 2 previous ones. So let's wait for Spacey. Let's go back to the experiment. And here I see that I've got the result of these 2 experiments. And I can check the quality, have a view on the quality. So meaning that I was able to split my data set in 2 parts, a training part to train the system, and then the test set to measure the quality. And it's exactly what I've got here. So what is interesting in this report, it means that we can present the precision, the recall, the number of examples we use in the test set, okay? And if I'm not happy with some metrics, at any times I can go back to the explore view, enrich, fine-tune my data set, and then run again my experiment, okay? Most importantly, now Spacey is over. So what I want to do is to compare each and every algorithm and to find the best one. So you see that automatically here, we see that the base one is the Delft one. And Delft is a framework running neural network. It's more or less the state of the art on some NLP task, especially for entity recognition. So it's what we see here. We have the best results with this engine. Okay. So what is interesting that again we are able to go back in the data set and to iterate and to see, okay, what do I need to do to enrich and to improve the accuracy, to the performance of my model. So now imagine that we find the best model, so which is here, the Delft one. And then we want to make a final test and to put it on production because we have some upcoming tenders to analyze, and we want to use this model on production. Okay. So what I need to do, actually, it's not a big deal. It's just to click on this button, and here, so I've prepared, okay, a call for a new tender here that I'm going to copy paste in the platform. And then just to check, I will click on the annotation using the Delft model. So in the meantime, what I want to show you is that behind this platform, everything is every button where I click on is using a web service. So we have developed a very important REST API, and that means that if I want to put my model in production, the first way to do that is to use the out-of-the-box web service for that. Okay, and this web service, you have all the element here that you will be able to integrate in your workflow. Everything is already done, and you just have to integrate this REST API. So the way to demonstrate the production system for me is just this test page, because here when I clicked on my annotation button, I send this upcoming document to the web service, and then I can check that automatically I've analyzed it and I've retrieved the right information, even with the date and so on. And you see here that I've got different date, but the good one has been selected. Okay, so now if we use the other model, so Spacey, for instance, which is a lower quality. So here you see that I've got the value, I've got the date, that's right, but the object is missing. So, okay, so too bad. And here, if I use CRF to annotate, again, here I've got the object, I've got the amount, but I don't have, I have two dates. So here, okay, for the example, it's not very relevant because it's the same one. But you see that here, the second weight has been picked up at the wrong place. So it's not the date I'm looking for. Okay. So that's, so I'm done with the demo. I hope it was valuable for you, and it was not too speed, but and Stefan, now what I propose is to stop sharing and to give you the hand back.
All right, thanks a lot, Vincent. So we were here at the demo, switching back. I hope you can see that. So what we have seen from Vincent is how he interactively, in a couple of minutes, trained a new model and then sent a new document with this test page through the newly created model, and that extracted the information that we want. But of course, if we want to do that in production, we won't be doing that interactively, clicking for each document anew. We would like to apply bulk processing, so some kind of a batch job. And as Vincent has pointed out, there is an API that allows you to do that. And I've given here two URLs that give you more information about that. One we have already seen, that's the Swagger user interface that explains in detail the REST API underneath the application that Vincent has shown us. And if you take a look at that, the professionals will find their way, but for the rest of us, it may make sense to have a little tutorial that explains us what we need to do. And this is the second URL here. There's a little tutorial that walks you through what do you have to do in order to make use of that API and create a batch process that, as we see it here on the right, takes a number of documents, walks them through the application, and leaves you with an Excel sheet that contains the information. Now, the scenario here is that it's, I don't know, Friday at noon, and the boss walks in and says, well, can you create me a table about the latest tenders that we need to respond to? And unfortunately, it's 500 of them. And rather than sitting down and extracting the information by hand, we apply this method that Vincent has shown us. We train a model, and we click a button, and then out comes, after the processing time that may take a couple of minutes, we get an Excel sheet that contains the answer that we were asked to compile. Now, attention, this, as opposed to what Vincent has shown us, which is, let's say, facing non-data scientists, let's say programmer domain experts, this here using the API requires a little bit of coding. So you need to embed the API into whatever client you have in mind. And if you take a look at this tutorial that we have put up here, you will see that even that with a few lines of code will allow you to get your job done. So what do we have? What have we seen? We have seen an example where with only showing via the mouse a couple of examples to the machine learns how to do the job for you. We don't code, we show examples. In the end, we are faster, simpler, and also often more accurate than what we could have done in large numbers manually. And this requires no technical expertise. So Vincent has used a number of these also already pretty advanced algorithms. So CRF is a conditional random field. SpaCy is a fine and beautifully engineered machine learning platform, an NLP platform. And then you have seen Delft, which is about the state of the art in deep learning. So there's all kinds of bilingual and bidirectional LSTMs underneath that you don't need to worry about. You just select the algorithm and give it a go. And if everything works right, you are happy with the results. So this is to enforce our claim here. You can operate this platform. You can get your job done without necessarily being a Python programmer or a data scientist. The studio accelerates the building of the training set. We have seen Vincent clicking a couple of examples, and then the machine sets in and in the background learns what Vincent has shown. And suddenly it creates suggestions, and these suggestions are pretty quick to accept or to refute, and constantly the machine is learning and learning and learning better. If we had a little bit more time, we could dive into the subject of active learning, which is how the system further accelerates the process of homing in on the ideal data set. But today is not the time for that. So just for you that you have heard the term. The system applies active learning methods. For the sake of this tutorial, for this webinar, we have chosen public tenders, but of course the scenario that we have described here applies also to other types of documents. So imagine you had to analyze hundreds and hundreds of contracts. Who signed this contract with whom? What is it about? When was it signed? What was the volume? And for instance, can I prematurely terminate the contract, or is that excluded in the contract? There are cases where people need to analyze, let's say, in some kind of a process like a due diligence, when a merger and acquisition is coming up, where they need to analyze large amounts of these contracts that can be nasty, legally very complex documents. And this could be one scenario for this application. You have seen Vincent presenting us a couple of these prepared projects that are on the platform right now. Some are about contracts, some are about customer feedback. A second example here could be invoices. I have an invoice, I mark up who sent this invoice when, to whom, about what, and what was the final amount. Easy to see if there's 5 and feasible if there's 50, but what if there's 5,000? I would hope I'm able to automate that task and maybe find the biggest one or find the latest one or something like that. Clinical trials, who has worked with what kind of drug, with what kind of substance to investigate which disease, which therapeutic field. And there are many, many more. And we would invite you to think about what kind of use cases you see in your daily practice that involve the analysis of large amounts of textual data, where you could well imagine to get some kind of help by automatic means. We have seen now how easy it is to set up a working process that results in a model that would allow you to automate that. In order to think about this question further, we would invite you, if you have such a question, if you say, that looks interesting. So tender is not really my domain, but we have other types of documents where people in my organization spend a lot of time analyzing them by hand. It's not the most sexy task, sitting down and going through hundreds and hundreds of documents by hand. If the machine can do that, that's even better. So drop us a line at info@Kairntech, and Kairntech.com, of course. We can arrange a free trial for you where you can play with these methods and see whether the use case that you have in mind falls within the parameter of what the software can attain. Uploading a number of documents, running the machine learning after you have annotated a handful of them, test the results as we have seen from Vincent, and iterate it until you're happy. This can be done by people with, as we mentioned, very limited machine learning expertise, but of course we are there to help if something comes up that cannot be easily explained. So please get in touch with us if you have use cases like that. We would be happy to sit down with you and explain you how they can be addressed. So we are in the schedule that we have foreseen. So we wanted to leave a couple of minutes before the show ends in order to address potential questions that you may have, comments. So where is my, I think I need to stop the sharing and take a look at the chat now. So is there something here?
So you can send your question in the chat.
So have you seen that? Okay, so
the
thanks
first
from our
question
side.
is,
Thank you
thank
for
you very
joining.
much.
Sorry, say it again.
No, the first question is from Paolo. It's thank you very much. So thank you, Paolo.
Okay, I've seen that. Yeah. So while okay. So Vincent, how are the segments produced?
Yeah, it's a good point, because it's in a project. It's really key. The preparation of the content is really key. So I was just chatting with Anzor, part of this call, regarding the OCR process, which may be key for some project when it comes to manage or to analyze a contract, for instance, because it's all about PDF in image. Then when we have the text, and especially for larger documents, it's very interesting to segment. So what we use today is a very standard algorithm using spaCy. We don't have any lot of customization for the time being, but the goal would be to fine-tune this segmentation, and why not to use machine learning models as well. So that means that we plan to support document structuration in the short term in the platform to make it possible to zone automatically, to structure a document, and ideally to segment some documents. So that's very important, and this is something that we want to further develop and to make it much more customizable, so as to improve the efficiency of the whole platform and solution. So for the time being, spaCy, and we do support 6 different languages, mostly European ones. No end-user customization for the time being, but this is something that we can fine-tune easily in the back end, I would say.
Very good. Thanks, Vincent. You mentioned that among the algorithms that you have experimented with, Delft was coming out with the highest quality numbers. This is something where we are a little bit proud, if you allow, because the Delft framework is a deep learning framework that is on the one hand side, open source. So everyone here and everyone worldwide can go to GitHub and download that and start experimenting with that. Now, for that one, it takes a little bit of data science expertise, but again, it's a platform that has confirmed numbers for standard evaluation corpora that represent the state of the art of what is happening in entity recognition. But not only is it is open source, but it's coming from our team. So the author of Delft is part of our team. It's our chief machine learning officer, Patrice Lopez. So while this system is open source and everyone can play with that and can apply it, naturally, since Patrice is part of our team, we know it a little bit better than maybe everyone else. So we have applied that, we have integrated that into the Sherpa, and as you have seen, it's competing very well. It's above the other two approaches that that currently are part of the application.
Yeah, we have new question regarding the format we can analyze. So basically, we support text format and JSON. So I would say that any electronic format, of course, when it comes to deal with PDF, we have to first transform them into text format. So if it's a PDF image, we have to use the OCR process. And if we have a PDF text, we just have to transform them into text format. So for the time being, we have to do this conversion, this transformation outside the platform, because natively we support JSON and text. But of course, in the short term, we will support additional formats natively in the platform, so as to be able to import directly PDF document in the platform. So there is a very important part on data preparation and data cleaning, which might be a challenge in some cases. But of course, on all the digital text, we can directly import in the platform. How your tools are language independent. So we have a small dependency on language, especially on the segmentation, because it's linked to tokenization and so on. But then beyond the segmentation, the algorithm of machine learning and deep learning are a little bit language dependent, but not so much, not so as we used to have with pattern recognition and regular expression, meaning that we have to build a data set depending on the language, and especially with neural network like the Delft framework, we can use language specific embeddings to improve the accuracy of such models. So that's more and more linguistic resources, more and more available into open access. And there are many initiatives all around the world to build these language models to boost the accuracy of deep learning models, like BERT, like ELMO, like FLAIR embeddings, and so on. So there are many things, upcoming things, and every month we have some new resources to take into account. So I would say yes, we have a language dependent, but it's less important that we used to have in the past with regular expression. So for us it's much faster to address a new language. Next question from Tim. Is it possible to integrate a thesaurus as a starting point for deep learning? Yes, exactly. So we will release a version in June with some pre-annotation capabilities, meaning that we will be able to use thesaurus or a big knowledge base like Wikidata to pre-annotate a corpus of documents, so as to bootstrap quickly the creation of data set, and hence experimentation with deep learning algorithm. So that's very interesting because within Kairntech we have already something that we have not demonstrated, but we have a system which is able to take the whole knowledge base of Wikidata in 7 or 8 languages and be able to analyze automatically and to extract the most relevant terms coming from Wikidata. And if you consider, for instance, the life science and the health industry, Wikidata is a huge hub of information on this area, and you have all the disease, so many symptoms and so medical entities that it might be very interesting to bootstrap a learning process with such a knowledge base or thesaurus. So yes, we will integrate very shortly thesaurus and more broadly knowledge base pre-annotation system to bootstrap deep learning algorithm or machine learning. So of course there is a link between that we have demonstrated today in terms of learning and models that we can create and put in place. There is a strong link with knowledge because for many implementation, if we don't link the extraction, even if it's based on a regular expression of our machine learning, it could be very important to link the system with a knowledge base to be able to identify uniquely some entities and to create a link and to create relationship and link to the knowledge base to make really a maximum of value for the companies, for the enterprise. Stefan, maybe you want to add something in this field because you're...
So maybe to elaborate on what Vincent has explained now, he mentioned a number of times now that something is in preparation for the interface that we have seen. So this is about the way that we work, that quite a number of approaches, like for instance, working with a thesaurus or working with, for instance, categorization, are earlier available on the basis of, let's say, non-integrated tools that we apply already in projects. And then we rush to make that also part of the interface that you have seen. So if you're talking about that question about annotating with a thesaurus, we have been doing that for quite some time, and there are API calls that allow you to do that. But as of today, it's not yet part of the application that Vincent has shown us. But it will be in the very near future. So I think by the end of June, you will be able to see that in the studio that you have seen. As of today, it's these let's say functions that we have seen. So the entity recognition based on manual or imported entities that are in the corpus.
So, and just a quick word on what I demonstrated. I presented a project based on name entity recognition. And for this type of project, of NLP project, we already exposed 3 frameworks of machine learning, CRF, Spacey, and Delft. We are about to release a Flare, which is also a kind of state-of-the-art deep learning framework. And on the categorization side, we have integrated the scikit-learn as a framework. So the goal is really to be able to integrate as many frameworks as we want, and ultimately to offer the possibility to our customer to integrate their own algorithm if they find something with a better quality, better accuracy. And to integrate in the platform to benefit from all the quality framework that we can propose to our users in terms of quality assessment, quality comparison, because we want to go further with some confusion matrix, with some different quality measurement on each and every model's algorithm.
All right, so I hope this scenario has underlined the core claim. We can address now tasks that I think it was feasible in the past as well to do something with computational linguistics methods that go through public tenders. But now we can do that with not much more than what Vincent has shown us, opening documents, annotating by hand a couple of examples, and then seeing a model getting better and better and better. So both Vincent and we are coming from a past where we have spent many, many years in a company that worked on a rather rule-based approach for these things. There's marvelous things that you can do with these approaches, but it's sort of reserved for the expert. It's reserved for people who dive into the language, know exactly what they are doing, and they have the patience and the capacity and the knowledge to use a rule-based algorithms in order to optimize these approaches. And what we see out in many, many clients and partners and organizations that we are working with is that there are these people, but often it's the biologist, it's the lawyer, it's the marketing expert, it's the security expert who doesn't want to sit down and learn a rule language. But still, documents need to be analyzed, information needs to be compiled, information needs to be prepared for decision-making progresses. And that's what the Sherpa is strong at, allowing also the people who are not Python programmers, who do not want to learn what it means to design their own neural network model, to address and solve these tasks. And that is basically what we wanted to show you today. I hope we have succeeded in giving you an idea about what that means and what that looks like and what that tastes when you're working with these methods. So we would be happy to hear from you if that rings a bell, if that is close to a demand that you see in your business or in the business of one of your clients or whatever. Please drop us a line and we together sit down with you and look into this case. Now, as mentioned, we are approaching the end of the show. Thanks again for joining. Thanks for your questions and for your interest. We will give you access to the recording and to the slides, and we would be happy to hear from you, either following up on this use case here or in one of the future webinars. So stay safe, stay tuned, let's keep in touch, and we wish everyone an excellent rest of the afternoon.
Thank you very much all, and have a good afternoon. Bye-bye.
Bye-bye.